Hello everyone, welcome to the next module. Today we will begin with question number 9. See, in all these questions that we had discussed earlier, like a 2 by 2 matrix, where we have to simply find out the inverse using the formula adjoint of A upon determinant of A. So today we will discuss about a 3 by 3 matrix, how to find out its inverse. So simply, first of all, we are going to find out the determinant. Let us expand along R1. So the determinant value is 2. Eliminate this, we get minus 1, minus 0, which is minus 1. Minus 1 again, because that's the positional value of 1. Eliminate this row and this column, it's 4 minus 0, which is 4. Plus 3, eliminate, this is 8, minus 7. So this is minus 2, minus 4, plus 3. Minus 2 minus 4 is minus 6, plus 3 gives us minus 3, which is not equal to 0. Therefore, we can write A inverse exists. Because had the determinant value be equal to 0, the inverse would have been undefined. So since it is not equal to 0, this means the inverse exists, it is well defined. Our next step would be finding out adjoint of A. Again, let's write these values. The positional value, this would be positive. This is negative. This would be positive again because this position is A1, 3. So 1 plus 3 gives us 4. Minus 1 to the power 4 gives us a positive value. Likewise, alternatively, we'll be having this negative, this as positive, this as positive, this as negative, this as negative, this as positive, right? So for 2, let us eliminate this row, this column and this row. So we have minus 1, write it in the bracket. Again, negative of this. So that's 4. 8 minus 7. That's 1. Likewise, we'll be finding it out for 1, 3, 2, 1. So that's 1 minus 6, minus 5. Again, eliminate this. So we have 2 3s, minus 7 and 1. So that's 2 minus 21. So that's 2 plus 21. That's 23. Okay. Next we have for this particular element 0. 4 minus 7. So 4 plus 7 is 11. Likewise, for this, we have 0 minus 3. 3. For this particular element, 0 minus 12. Minus 12. And for this element, it will be minus 2, minus 4, minus 6. We'll find out the transpose, which will give us the adjoint value. This is minus 1, minus 4, 1. This is 5, 23, minus 11. This is 3, 12 and minus 6. So what is the inverse? Inverse is 1 upon determinant A, that is 1 upon minus 3 into adjoint, that's minus 1, minus 4, 1, 5, 23, minus 11, 3, 12 and minus 6. So this is how we find out the inverse of a 3 by 3, given 3 by 3 matrix, right? One more question we'll do of the same order. That's 3 by 3 matrix where we have to simply find out the inverse adjoint of A upon determinant of A, right? So first of all, let's find out the adjoint. Or before that, let's find out the determinant. So we'll get to know whether the inverse exists or not. So we have 1 expanding along R1. So we have 1. This is minus cos square alpha minus sin square alpha minus 0. This will give us, since this value is 0, so we'll get the value as 0 for the entire term, plus 0. Taking minus common from here, so we have cos square alpha plus sin square alpha, that's minus 1, which is not equal to 0. Therefore, A inverse exists. Then, adjoint of A. Now, adjoint of A is, remember, simply, this will be positive, negative, positive, negative and positive, positive and negative. This is negative and positive. So that's minus cos square alpha minus sin square alpha. Again, taking minus as common, we get minus 1. Likewise, here, eliminate this particular column and this particular row. We have 0 and 0, so that's 0. Likewise, eliminating this, again we get 0. Likewise, for this particular element, we get a 0 again. For this particular element, this is minus cos alpha minus 0. So we get minus cos alpha over here. Likewise, here, for sin alpha, eliminate this row and this column. So we have sin alpha minus 0. That's minus sin alpha. For this particular element, it's again 0. For this element, it will be sin alpha minus 0. So that's simply sin alpha. And for this particular element, it would be cos alpha minus 0. Transpose of this, minus 1, 0, 0, 0, minus cos alpha, minus sin alpha, 0, minus sin alpha, cos alpha. So that's the adjoint, and A inverse is adjoint of A upon determinant of A. So adjoint of A, minus 1, 0, 0, 0, minus cos alpha, minus sin alpha, 0, minus sin alpha, cos alpha, minus 1. So what we can do is, let's multiply every element with, since 1 upon minus 1 gives us minus 1, let's multiply all the elements with minus. So what do we get? 1, 0, 0, 0, cos alpha, sin alpha. This gives us 0, sin alpha, and minus cos alpha, right? So as we can see, this matrix and the given matrix, they are exactly the same. So the inverse is the same as the matrix itself, right? So this is question number 11. I hope you're understanding, students. Next, let's move on to question number 12. Right. In question number 12, matrix A and B is given to us. We have to find out AB inverse is equal to B inverse into A inverse. So what do? We first of all find out determinant value of A and the determinant value of B. Or let's find out B inverse and A inverse separately. So determinant of A, that's 15 minus 14, which is 1. And B, 9, 6 are 54, minus 56. So that's minus 2. Right? Cross multiply 15 minus 14 and 54 minus 56. So we get minus 2. Now, A inverse also exists since this is not equal to 0, and B inverse also exists. So let's find out the value of A inverse, right? And then B inverse. So for that we need to know adjoint of A. Now what is adjoint of A? Remember, if I have to find out the adjoint, this will be a positive position, this is negative, and this is positive, and we'll be finding out the transpose of that. Now eliminating this column and this row, we have 5. Eliminating this row and this column, we have 2. Eliminating this and this, we have 7. And eliminating 5, we have 3. Right? We need to find out the transpose. So it's 5 minus 2 minus 7 and 3. Likewise, we'll be finding out adjoint of B. Adjoint of B would be again, this is positive, negative, negative and positive. So eliminate this column and this row, that's 9. Eliminating this particular row and this particular column, that's 7. Eliminating this and this, we have 8. Eliminating this, we have 6. Find out its transpose. So this is 9 minus 7 minus 8 and 6. Likewise, what is A inverse? Adjoint of A upon determinant of A. One upon A, determinant of A, that's 1. And B inverse here is right. This is what we find out. Let's find out the RHS now. We found out A inverse and B inverse. RHS is B inverse A inverse. So B inverse is, if I take this minus 2 inside, so I have minus 9 upon 2. Minus 8 upon minus 2 gives us 4. Minus 7 upon minus 2 gives us 7 by 2. 6 upon minus 2 minus 3. A inverse. So that's 5 minus 7 minus 2 and 3. Now, simply multiply. Minus 9 by 2 into 5, that's minus 45 by 2 minus 8. Likewise, we have minus 9 by 2 into minus 7, 63 by 2 plus 12. Likewise, we have 35 by 2 plus 6, and here we have minus 49 by 2 minus 9. On simplifying, we can get 45 and this is 16. So minus 45 and 16 gives us minus 61 divided by 2. Simplify it. 63 by 2 plus 12. So 63 plus 24, that's 7. 107 by 2. Here we have 35 by 2 plus 16, that is 12, which is 47 by 2. And here we have 49 and 18, so that's 17. So that's minus 67 by 2. So this is our B inverse A inverse, right? Next we'll be finding out AB inverse. For that we need to know AB. 3, 7, 2, 5, and this is 6, 8, 7, 9. So AB would be 3, 6, that's 18 plus 49. We have 18 plus 49. This is 24 plus 63. Likewise, we have 12 plus 35. And here we have 16 plus 45. So this is 67. Likewise, this is 87. This is 47. And for this we have 61. Right? Coming back here, this is not 80s, this is going to be 87, not 107. This is 87 by 2. Right? Now we need to find out AB inverse. Right? So AB inverse would be adjoint of AB upon determinant of AB. So let's find out determinant of AB. Determinant of AB would be 67 into 61 minus 87 into 47. Right? Now let's simplify this. So 67 into 61 gives us 67, and 4087 minus, that's 4089, right? So this is equal to minus 2. Okay, so that's the determinant. Therefore, AB inverse exists. Let's find out the adjoint of AB. This should be positive, this is negative, and this is positive. So for this, it will be 61. For this particular position, it should be 47. For this position, it will be 87. And for this position, it should be 67. Finding out its transpose. So that will be 61 minus 47 minus 87. And this is 67. Finding out AB inverse. Remember, that's adjoint of AB upon determinant of AB. So determinant is minus 1 by 2, 61 minus 47 minus 87 plus 67. And this can be written as 61 minus 61 by 2, 47 by 2, 87 by 2 and minus 67 by 2. And this is exactly equal to the RHS. This was our left hand side, and as we can see, this is exactly equal to the right hand side. Okay, so this is how we find it out. Coming to the next question. Question number 13. In question number 13, matrix A is given to us. First of all, we'll be proving a square minus 5a plus 7i is equal to 0, and then we'll be finding out A inverse. So such a question comes all together. And remember, inverse can be only found if this expression is equal to 0. Otherwise, we cannot find out the inverse. Okay. A square minus 5a plus 7i. We have to prove it equal to 0. For that, we need to find out a square. So that's 3, 1, minus 1, 2, and that's 3, 1, minus 1 and 2. 9 minus 1, 8, 3 plus 2, 5, minus 3, minus 2, minus 5, minus 1, 4, that's 3. Putting the values, we have 8, 5, minus 5 and 3, minus 5, 3, 1, minus 1 and 2, plus 7, 1, 0, 0, 1. This is 8, 5, minus 5, 3, minus 15, 5, minus 5, and that's 10, plus 7, 0, 0, 7. 8 minus 15 plus 7. 8 plus 7 is 15. Minus 15 gives us 0. 5 minus 5 plus 0 gives us 0. Minus 5 minus 5. That's minus 5 plus 0 gives us 0. And 3 minus 10 minus 7 plus 7 gives us 0. So this is equal to a null matrix. We have proved this. And hence we'll be finding out the inverse using this particular expression. So how do we find out the inverse? We'll be pre-multiplying the above equation with A inverse. So if we pre-multiply the equation with A inverse, our equation is A square minus 5a plus 7i is equal to 0. Pre-multiply it. So this means A inverse A square minus 5 A inverse A plus 7 A inverse I is equal to 0. This is how we multiply it, right? So multiplication means we'll be multiplying it with A inverse. Means A inverse value will come first, followed by the matrix values, right? Now A square, A inverse A square can be written as A into A minus, what is 5 A inverse into A? It's identity matrix we had done in the previous exercises, plus 7 A inverse I. Any matrix or its inverse multiplied with an identity matrix gives us that matrix itself. So it will be 7A inverse. Likewise, here A inverse, A is I. Here I into A gives us A minus 5I plus 7A inverse is equal to 0. And what is matrix A? We'll be just writing it here. A is 3, 7, 2 and 5. 3, 1, minus 1 and 2. I is 1, 0, 0, 1. We have to find out the value of A inverse. So this is 3, 1, minus 1, 2. That's minus 5, 0, 0, 5 plus 7A inverse is equal to 0. Now 3 minus 5 gives us minus 2. 1 minus 0 gives us 1. Minus 1 minus 0 gives us minus 1. And 2 minus 5 gives us minus 3 plus 7A inverse is equal to 0. Minus 7A inverse is equal to minus 2, 1, minus 1, minus 3. Or simply A inverse is equal to minus 1 upon 7, minus 2, minus 1, 1, minus 3. So this is how we find out the value of inverse using a given equation. I hope it's clear to you students till here. In the next class, we'll start with question number 14. Thank you.